We'll see. I like it because the colors are weird. Okay, so if I had the problem f of x equals x to the fifth, and I wanted to find the derivative, what would I do?
Just bring down the 5 down to 4.
Okay, so it would be 5x to the fourth. Done. All right, what if I said f of x equals ax squared? What do I do?
It's just 2ax.
Yeah, so you still bring the exponent down to the front, so that'd be 2 times a, and then x to the first power, or you don't have to put the 1, you could just say x. That would be fine. Okay. What if I had x to the fourth divided by 4?
Well, then you bring the 4 down, and then it cancels out, and then you get x to the third.
Yeah, if you need to think of this as 1/4 x to the fourth, that's what I typically do. I typically rewrite it like that because it makes it easier for me to think of it as an expression with a fraction coefficient as opposed to like a rational expression. That's easier for me to think of. So we bring the 4 to the front. 1/4 times 4 is just 1. So we've got 1x to the third, or you don't even need the 1 on the front. You could just say x to the third. All right, what if I have then it's 0.
Because if you plot 3, then the slope is always going to be 0.
Yeah, this is a horizontal line. It's a horizontal line. And so if you say what's the slope of a horizontal line at any individual point on the line, it's always going to be 0 because it's horizontal. Another way to think of that is you could say that's the same as 3x to the 0. That kind of falls apart a little bit though because you can't drop the exponent by 1 and get the right answer. But the idea is you're like multiplying
Then you end up with like
a rational.
3 over x.
Yeah.
Yeah, now that doesn't.
Well, you'd actually end up with 0 over x to the 1,
Well, I mean,
and that
so
kind of works.
So the real shortcuts are actually, you got here x to the a is equal to.
Yeah, and 0 over x.
It's really
Right.
The derivative of x to the a plus c, where c is some constant, is equal to ax to the a minus 1.
Yeah.
Because the c just
Right.
So just in general constants. Yeah.
All right, what if I have 2x squared minus 5x to the negative 2?
Well, then you got your nice old well, the second term turns into 10 over x cubed, and the 4x.
So drop the 2 to the front. So 2 times 2 is 4x to the 1, right? Plus, yeah, so I'll say 10x to the negative third, just showing all my work. So I've got 4x plus 10 over x cubed. Yeah. And both of these are good answers. I would prefer the second one because I like for you to practice converting things and simplifying them. For an FRQ, either answer would be fine. For multiple choice, the second answer is probably the one that would be there. Okay? Yeah. You take negative 2 and you subtract 1 from it. So when you're doing the derivative rules, I would say most people understand the idea of bring it to the front, subtract 1. The little mistakes you're going to see is when you have a negative and you're subtracting and the number's actually getting bigger instead of smaller, and then maybe making a sign off in the front or something like that. Those are some mistakes we see, but I don't think this is necessarily, like the concept I don't think is too hard for you. I think that if you move too fast, you're going to make mistakes. All right, here's another one. How did you guys feel about the product rule and quotient rule?
Our rule is easier than the quotient rule.
But the quotient rule has the, yeah, it's kind of a nice little. All right. Ooh, I have one for you. We're gonna see how we like this one. We're gonna do this first, and then we're gonna go into the product rule and quotient rule. So a over x minus b over x to the third. a over x minus b over x to the third. Somebody other than Wolf. Sorry, Wolf.
A over X.
A, that's A over X.
So you just make this ax to the negative 1 minus bx to the negative third.
Yes.
And then from there.
Yes. So when you're doing problems like this, that's kind of the little trick to it, is that when you first look at it, it's like, ooh, is that like a mini quotient rule problem? You could use the quotient rule, but that would be terrible. The easier thing is to rewrite it, and then it makes it an easier problem to deal with. So now if we look for the derivative, what do we have for the first piece?
1.
Negative ax squared to the negative 2.
Yeah, there you go.
It's getting bigger, not smaller.
Plus 3b x to the negative 4. Okay, and then if we were to write those with positive exponents,
3b over x to the 4th minus a over x squared.
yeah, so you can switch the order. That's what Wolf was doing, is he was switching the order so that the highest, and actually you would still do it in this order because x squared is on the bottom is bigger than x to the 4th on the bottom.
Yeah.
But he was in his head, he was doing the bigger exponent first.
Yeah, just aesthetically, I like it if the positive is first and then negative. It looks nicer.
Mm-hmm. Yeah, that's fine.
No, it isn't.
All right.
Well, mathematicians
We, they would leave a negative in the front if the exponent was higher.
I mean, I do that every fall and over, but I guess
All right. Ooh. I'll get that lid in a second. All right, here's another one. If we have f of x is x to the 4th plus 6x squared minus 7 over x, how could I rewrite that problem so that I don't have to use the quotient rule?
you write it as factor.
What do you mean by factor?
I think their grade is coming.
There's no GCF. You could factor this probably 7 and negative 1, but you don't need to factor it. You can think of it as like, oh, they had 3 fractions to start with and they had a common denominator, so they added them all together. So yeah, so we're gonna split it apart. Yeah. See how easy it can be sometimes to avoid that quotient rule? So x to the 3rd plus 6x minus 7x to the negative 1. And now we're ready to find that derivative. Mm-hmm.
Plus 1.
So think about how this one would work. Plus 6, right? Because it'd be 6x to the 0. And you were right, that x to the 0 is 1, but there's still a 6 there. And then what do we have? 7x to the negative 2, which we would rewrite.
Wait, if we were making a polynomial, would the 6 be before the x to the negative 2 because it technically has a higher exponent?
Mm-hmm, because it has an x to the 0.
Mm-hmm.
Yeah. All right. So now let's look at some product rule. All right. Let's say we have 2x to the 3rd plus x times x squared minus 5. And if you wanted to avoid the product rule, you could FOIL it out and then do each piece separately. That's valid. But here I'm forcing you to use the product rule. So you have to. So how do we do the product rule? The order doesn't matter. In my head, on my answer keys, I've memorized it as first times the derivative of the second plus the second times the derivative of the first. I will not mark you wrong, but it will mess with my brain. If you're like, Ms. Rice, see what I did wrong? I had students last year who always did it like the backwards version, and they got it right, but every time I had to check their work for something, I got so confused. So I'm just telling you, if you look at my answer key, that's how it's always going to go. So if we do it the way that I prefer it, we do first times the derivative of the second, so I'm going to keep the first one the same. And what's the derivative of the second piece? X, okay, plus the second times the derivative of the first. So I'm going to keep the second exactly the same. And what's the derivative of the first?
4x.
That's a 3. 3 times 2, 6x squared, plus 1. Okay, so, and now what do we do? Yeah, now we just distribute, clean it up, make it look nicer. So what do I get for the first two terms?
4x to the fourth plus 2x squared.
And then this actually has to be FOILed. So what do we have?
6x to the fourth plus x squared minus 30x squared plus or minus 5.
Okay, so we've got 10x to the fourth. Yep, 3 and negative 30 minus 27 x squared minus 5. But there's no reason to.
Do it for fun.
Yeah.
Exactly. I mean, come on.
I don't even know how to factor that.
Yeah.
I mean,
Will you ever learn how to factor something like that?
If you were to factor something that had an x to the fourth and an x squared, then you just have x squareds and x squared instead of x and x. It would be like a slight divide problem, yeah.
That still doesn't factor cleanly enough.
I don't multiply to negative 50, add to negative 27. I don't think so. No. All right, so let's go ahead and practice the quotient rule. We'll probably come back and do more product and quotient rule later on in the assignment when we get to it. But let's do this one. F of x is 2x plus 2 over 5x minus 3. And on this one, when we remember the little shortcut, the order matters. So you can't be like, oh, if I get it backwards, it's fine. It's not fine. It has to be the same. Okay. So what's the little saying?
Low D high minus high D low over low squared.
Okay. So, and you guys understand what I'm saying when I mean that? What I mean when I'm saying that? Low, yeah, low D high. So we're gonna say start with the bottom. D high, so times the derivative of the top, which is 2, minus high D low, so keep the top the same, and what's the derivative of the bottom? 5, divided by low squared. And can I take that 5x minus 3 and one of these 5x minus 3s and cancel them? No, that would kill a puppy. Why would that kill a puppy? Yeah, this is a subtraction problem on the top. It's not all multiply and divide. We've got something subtract something. That's why we can't cancel.
We'd have to break it into 2 fractions.
All right, so let's go ahead and clean this up a little bit. So we've got 10x minus 6 minus, I'm going to go ahead and put this part in parentheses. And then what do I get here? Okay.
And then those 10x's immediately die.
Yeah, 10x and negative 10x. and a negative 6 and a negative 10. So that's going to give us a negative 16 over 5x minus 3 squared. This would be, the reason why it ends up on the bottom like that is because this would be a complex fraction, and you would have that part where you multiply by the common denominator on top and bottom, and that's what ends up there, why there's two of them down there. Okay, so you have an assignment. It's on Larson page 135. Actually, real quick, I'm going to show you something. I need you to get out your calculators. I'm going to show you how to check a derivative at a point on your calculator.
Oh, well, I already did this video though, so.
All right, go ahead and, yeah, for y1, we're going to type in x squared. And go ahead and make your window normal. And we're going to hit graph. Now, the thing about your calculator is, unless you have one of the really fancy TIs like TI 89 or higher, your calculator will not, you can't say, hey calculator, if I give you the function, tell me what its derivative is written as an equation. Your calculator is not going to do that. But if you want to know what the derivative is at a specific point, your calculator will tell you that, okay? So if you have graphed it, you can hit second trace. And if you go down to where it says dy dx, we now recognize that as what notation? Derivative. So if I want the derivative of 5, so what am I going to ask? What am I asking my calculator right now? What does that mean? What does derivative at 5 mean?
The derivative at x equals 5.
The slope, right? The slope at an x value of 5. If our function is x squared, what's our derivative as an equation? Using the shortcut, 2x. And if I plug in 5, what do I get? 10. So my slope at an x value of 5 is 10. So your calculator, it can tell you derivatives at specific points. It just can't tell you the equation of the derivative. It's not going to spit that out, but it's going to give you the points, okay? If I want to do it again, I could say, find me the derivative at negative 3, and what's it going to say? Negative 6, right? The reason it says invalid is because your window did not go to 78, but if you change your window to go to 78, then you can ask what the derivative is 78. So if you change your window to 78, now you can go in and plug in 78 and it will give it to you. So your calculator, when you're using your calculator to evaluate something and you're in the graphing mode, it will only let you plug in x values that are on your window. So if your x goes from negative 10 to 10, those are the only values you can plug in. So if you want to plug in something bigger, that's fine, just make your window bigger. Okay.
What happens if you plug in like 1 over 0.001? Like what is the window? How big does the window go?
If you plug in what?
Like 1 over equivalently 0, but not 1.
You might just, so your calculator, it kind of spins when it's thinking. You might just make it spin for a really long time and have it like freeze on you. Yeah. Yeah, so here's the other place that your calculator will do the same thing. So if you hit the math button, everybody do it real quick, hit the math button. We're going down to number 8. So d dx, I'm gonna go ahead and plug in x there. D dx, so if you're doing, if you're finding the derivative of a function that has a different variable, you can use different variables here. So I'm saying d dx as the derivative of x, and I'm going to go ahead and put x squared, evaluated at 5. So it's a different notation, but it's the same thing. So I'm telling my calculator, find the derivative of x squared when the x value is 5. And it's going to tell me 10. Okay? So your calculator, you can do it graphically, or you can do it on the screen like this. These are good things to remember, not that we're to be able to do them a lot on our test because a lot of our tests are calculator inactive. But in a pinch, when you need to find a derivative really quickly, this is the way you're going to do it. Okay, a derivative at a point really quickly. You're going to do this way. All right, make sense? Okay, so your two options were to graph it, and when you graph it, you can do second trace and do option number 6. Your other option is to do it without graphing it, hit the math button, and number 8. Math number 8 will get you to your derivative evaluated at a point. Those are two different ways to do it. Okay, so go ahead and start working on the assignment. I redid the numbers that you guys are doing today, so I do not have an assignment, like an answer key to put up on the board, which means I'm gonna work on it right now too. Okay, so if you need to see an answer, just come creep and look over my shoulder.